Over the page now, I've just turned it here. Took the liberty of preparing the axes. So here we have the y-axis and the x-axis. The question says, draw a graph on the x and y axes from 0 to 6. I've done that. Shade the region where x is greater than 5. So let's just define the region. X must be greater than 5. In other words, that's why I drew a dotted line there, because I'm not allowed to be on 5. And y has got to be greater than 2 but not equal to it. That's why I drew a dotted blue line to represent the equation of y equals 2. And y has got to be less than or equal to x, and because it says equal to x, I drew a solid red line using my line facility right there. Now let's look at it carefully. I've got to shade the region where these three inequalities are true. So let's just take it one at a time. X has got to be above 5. Alright, just check it carefully. Sorry, x has got to be below 5. I read it wrongly from the side. So excuse me, let's just correct that. X has got to be less than 5. In other words, I shade everything to the left of the x equals 5 line. Alright? But not everything. I've got to be above the y equals 2. So in other words, I mustn't go below the blue line. Alright? And finally, my y has got to be less than or equal to my x. In other words, below the red line. So let's just recap. I've got to be to the left of x equals 5. I've got to be above y equals 2. And I've got to be below y equals x. Well, if you take all that into consideration, this is the region where all these three inequalities come into play. And once I've shaded some of it in, obviously you don't spend hours doing this in an exam, it's just that I'm on a video now and I can afford to spend a little time doing it. Right, all that is a required region, and traditionally you put an R there just to show it. Alright, let's just check. Is this yellow patch less than x equals 5? Yes. Is this yellow patch above y equals 2? Yes. Is this yellow patch below y equals x? Yes, it is. Now let's just test it out with a valid point. In fact, let me just get rid of this black thing, I'm going to need it later. So let's just smudge that out. Okay. In fact, it says, part B, list the three coordinates in the region where the coordinates are integers. Right, so let's have a look. I've got the point 4, 3. Yes, I've got the point 4, 4. I'm allowed to be on the line. It says equal to there. Look. I'm allowed to be 3, 3. Because y equals x, 3 equals 3, and I'm allowed to equal to it. And that's it, really. Please look at this point here as a test point. These are only three valid points that fit within the constraints of the three regions: x less than 5, y greater than 2, y is less than or equal to x. Let's just test it. Is the x coordinates less than 5? Yes, it is. Is the y coordinate here, 4, 3, greater than 2? Yes, it is. And is the y part of the coordinate, 4, 3, is the 3 less than 4? Yes, y is less than x. Therefore, on all three counts, that's the correct region. And so the coordinates are within the region that they've asked for. We've got the point 4, 3. We've got the point 4, 4. And we have the coordinate 3, 3. So these three coordinates fit within the region, and they are bound by the constraints of these three inequalities. Alright? And the final question is pretty good, because we will get to revise gradients. Right, find the equations of the gradients. This is question 4, I believe. Yeah. Find the equations of the straight lines of these graphs. Well, let's work in yellow because we need to be bright here. If you look over here, I can take any size triangle I like. Look at that. Let's take the biggest I can get. So from 3 down to -3, I've got 6 units, and from -3 across to 3, I've got 6 units. So the gradient's going to be, it's going to be negative, you remember. So the gradient's going to be, it's going to be -6 over 6, which is -1. Alright, so here I go. So, and where does the intercept cross? It crosses at 0, 0. Therefore the equation is y equals -x, negative 1x. Alright, so that's the actual graph itself. And then it wants me to name that region. Well, that's not very difficult. I know that's y equals -x. So let's just do a little arrow there because it's a lot easier just to work up here now. That's going to be y is less than minus x. Again, if I take a test point here, if I take that point there, we have minus 2, and let's just write it down here, minus 2, is the y value less than minus x. So if that's minus 2 and that's minus x, well, minus x would be 2. Therefore 2 is greater than minus 2 for the y, and minus 2 for the y is less than the negative value of the x. Very tricky, because minus x is minus 2, therefore x is 2, and therefore it's quite hard to explain it. Anyway, that's definitely the correct region. Sorry, I can't be any clearer than that. You need to study that yourself. Unfortunately, we're playing with negative gradients, and that affects the way, the clarity with which I'm explaining it. Let's just do the next one, hopefully get into it a little bit better. Now, this equation here, I'm going to take a great big triangle again. So from there to there, I've got 6 units, so that's 6 along there. And from minus 2 to 4, I've got another 6 units, if you look carefully. Minus 2 to 0 to 4 is 6. So again, the gradient, or m, is going to be 6 over 6, which is 1. And please note the intercept is 0, 2. So I've got y equals 1x, mx, single x, plus 2. Therefore, what's the region here? Y is greater or equal to x plus 2. This is much easier to test out because we're in positive territory and we have a positive gradient. So what have I got here? I've got x is 1 and y is 4. Put it inside there. When x is 1, I've got 1 plus 2 is 3, and is y greater than 3? Yes, y is greater than 3 because y is 4 at that point. Is that alright? So that's correct. Now the next one looks a little bit more difficult, and let's work in blue so it stands out. Again, take a nice big triangle. So I'm going from 0 all the way down to minus 5. So this little part here is 5 units long for the y, and from minus 5 across here to 0, that's like going across there, I've got another 5 units. So therefore I have a gradient of minus 5 over 5, because it's a negative gradient, otherwise known as minus 1, and the intercept on the y-axis is 0 minus 5. So I've got the equation y equals minus x minus 5. Alright, therefore the region, which is the shaded bit that they require in the question, is this part here, and I've got y is greater than minus x minus 5. Is that alright? Actually, I want to go back to the question on page 79, question 4, and I want to explain further why the region here is in fact y is less than minus x. I tried to use the coordinate minus 2, got in awful bother there, so I'm going to get rid of that and do a different test point. If I take the point 1 minus 2, that one there, so I've got the x coordinate of 1 and the y coordinate of minus 2. Now, let's just test it. Y has got to be less than the negative value of the x coordinate. Alright, so if x is 1 and y is minus 2, that coordinate is in the region that I require. So is it true? Is the y value less than the minus value for x? Well, x is a positive 1 value, but the equation says minus x, therefore minus 1 instead of 1. Is minus 2 less than minus 1? Yes, it is. It's completely true, and therefore this test point is sitting in the correct region, and we've named the region correctly. That is the region y is less than minus x. And I make this little addition, and I'm going to sign it off as done, and I'll look at the questions in the assess quite soon.